All right, so that gets us to the conclusion of our discussion of sets. And next up, we're going to take a look at the Python dict, or dictionary. The other containers that we've looked at, list, tuple, and set, contain individual items or elements. A dictionary is different in that what it contains is key-value pairs where the key and the value are separated from each other with a colon. So an item stored in a dictionary is this key-value pair. The items are stored in the most recent Python implementations in order of key creation. So the first item that you add to a dictionary remains the first item, and so forth. You're not allowed to have duplicate keys. Like the elements in a set, the keys have to be hashable. Okay, so there are these restrictions on keys. Keys have to be unique, keys have to be hashable, items in a dictionary are stored in order of the key creation. There is no restriction at all on values. Values can be the same as each other or unique from each other. They can be mutable, immutable. A dictionary can have a key with a value that is another dictionary. There's no restriction whatsoever on the values associated with keys. Here I'm creating a dictionary named N to E. The idea of this is to create a mapping, if you will, from a user name to that user's email address. So name to email is what N to E is an abbreviation for. I'll go ahead and define this dictionary. All right, so my key has to be hashable. A string is hashable. So I can use John, in quotes, as one key. And the email address for John is jkostlund@gmail.com. I'll type that in. Okay, so there's the first item in my N to E dictionary. The key is John, the value is jkostlund@gmail.com. Which works, by the way. That is an email address for me. Because I'm defining the dictionary in curly braces, I can go ahead and press the Enter key after a comma and just keep typing. My next key is going to be Al, and Al's email address is al@alcorp.net. And then I'm going to type my next item, which in this case is Bob, and he is Bob at basoc.com. There we are. So I have now successfully typed in the definition of a dictionary containing 3 items. The items are these 3 pairs: John and John's email, Al and Al's email, Bob and Bob's email. If I ask for the type of this object that I've created, I see that it is a dictionary. As another example of a dictionary, S to S stands for student to score, and instead of email addresses for values here, what we have is a list of quiz scores for each student. So my first student is Cal. I'm going to go ahead and just type this in and get back to you in a minute. Okay, so my student to scores dictionary also has 3 items in it: Cal, Dave, and Ed, and their scores for 3 quizzes. The scores are stored as a list, so each item consists of a string for a key with a list for a value. Ed's second item in his list is none. Probably Ed had an interview on the day of that quiz and hasn't made up the quiz yet. So none is a placeholder to indicate that there's no score there yet. A dictionary is iterable. It's not a sequence, So if I try to say something like n to e sub 0, I get nothing. The square brackets are actually used to look up the value associated with a particular key. And in my n to e dictionary, there is no key 0. There is, however, a key John. So if I look up the value associated with the key John, I see J.K. Ostlund at Gmail. S to S, student to score of Ed, shows me Ed's 3 scores. And because that's a list, I can also do indexing on that list. So I can look up the list of scores associated with Ed, and in that list I can use the index sub 0 to look at the first item in that list. So Ed's first quiz score was 94. If I try to look for a key that doesn't exist, as I actually already demonstrated here was 0, if I look for a key that doesn't exist, like n to e of Mary, then I get a key error. Adding new items to a dictionary is easy. You can use the square brackets to specify the key, and in this case, rather than looking up the value associated with psi, because there is no such value yet, we are going to define a value to be associated with that key. So psi at nou.edu will be the value associated with the key psi. All right, so n to e now has grown by 1 item. And in fact, I can ask how many items there are in that dictionary with len. You can see these are in key creation order. A dictionary is mutable. If I look up John in my n to e dictionary, John already exists. Perhaps I want to change the email address associated with that username John. All right, so here I am updating the value associated with the key John in this dictionary to jostlund at andrew.cmu.edu instead of the Gmail address. All right, so as far as basic sort of high-level properties, a dictionary is iterable. By default, it's iterable over keys. So if I use a for loop, let's say k in n to e, what I will get from the dictionary n to e is the keys of n to e by default. Okay, so the dictionary is iterable. It is mutable. As we've seen, we can add more elements to the dictionary. We can change values associated with existing keys in the dictionary. It's not a sequence, so we can't do things like slicing. The square bracket notation is used for dictionaries, but it does a key lookup rather than an integer 0 through whatever subscript. A dictionary is a collection. It's considered to be a collection on keys. So if you ask whether something is in or not in the dictionary, what you're actually checking is the keys. All right, here is my n to e name to email dictionary. I can ask whether John is in n to e. That's true. Fred in n to e is false. If I look for Andrew, well, I have to be able to spell or type. If I look for Andrew in n to e, I get told false, because the only things that are being checked by in and not in are keys. We're not looking at the values or parts of the values within the dictionary. All right, so these examples here on slide 23 are similar to things that I've done. S to S is student to scores. The number of items, the number of key value pairs in S to S, is 3. Dave is in S to S, but 100 is not in S to S. Now, there are a couple of scores of 100 in the value parts of a couple of items, but when we use in, we're looking for keys. Okay, so here on the top of slide 24 is another illustration of using a for loop to go through the keys of a dictionary. We can use the key that we found to access the dictionary itself from within the for loop. Here I'm saying for k in S to S. So this is for key in student to score. I want to print out the key, and the last score that this student achieved on a quiz, S to S sub k, is the list of scores, and sub 2 is the last score. In fact, if I really wanted to be careful, if I weren't sure how many scores there were, I could say len of S to S sub k minus 1. Okay, I'm really pushing my luck there. All right, so the last score for the student whose key, whose name is k, is S to S sub k. That's the key value pair. Because the value is a list, I can look up a particular item within that list, and in this case I'm saying I want to look at the last item in that list. And so if I remember to type my closing parenthesis at the end of print, I will be able to see, whoops, okay, I really messed this up, sorry. Let me quickly copy and paste this. My mistake as probably you noticed, is out here at the end of the print. The parentheses, this parenthesis character should be here. Okay, so S to S sub k, the length of that, minus 1, will give me the score, and I use my parentheses, and I'm all set. All right, well, I'm sorry for goofing that up, but there we are. You can entirely eliminate an item from the dictionary by using the delete command. If I say del of S to S sub Dave, then S to S no longer contains Dave at all. Dave and Dave's value have been eliminated. D.clear will wipe out all of the values in D, but leave D remaining. So if I say S to S dot clear, S to S still exists, but S to S is empty. Notice that open and close curly brace indicates an empty dictionary. S to S is a dictionary. Curly braces are also used to create a set, but an empty set is indicated by the notation set open close paren. Okay, so this is an annoying little tiddly difference to remember between creating an empty dictionary, which is just open and close curly, versus creating an empty set, which requires you to use the constructor name set with empty parentheses. I can make a shallow copy of a dictionary, and I can also pop an item from the dictionary. The order for popping items from a dictionary is well defined. The last key that you added to the dictionary is going to be the first key that's popped. All right? So I still have N to E sitting around, which has 4 keys in it. If I say n to e dot pop item, I claim that the last item is the one that should be popped, and it's going to be popped as a tuple. So rather than a key and then a colon and a value, I'm going to get a tuple containing the key and a comma and the value. So this is a key value pair represented as a tuple. Now, one way to get the value for a particular key, as we've seen, is to use square brackets. So if I say n to e sub John, I get the value for John. If I say n to e sub Joe, I get a key error because there is no Joe in the dictionary. As an alternative, I can use the get method with a key, and that will never result in a key error occurring. If the key that I'm looking for doesn't exist, then what I'll get back by default is none, or I can specify the default that I would like to get back from get. All right, so rather than using square brackets to look for Joe, let me say d.get Joe. Well, let me say n to e dot get Joe, and I get back none. Well, none doesn't display, so let me show that what I got back was in fact none. As an alternative, I can specify something other than none that I would like to get. Pop is another alternative to the square brackets. Pop allows you to specify a default that you would like to get back if the key does not exist. If the key does not exist and you don't specify a default, you get a key error, just as though you had used the square brackets to look up the value for a non-existent key. Okay, so these examples here are similar to the ones that I've already done. I'm not going to repeat going through these. You can try them out yourselves. Okay, so here we're discovering that there are 3 items at this point in the N to E dictionary. If I delete one, there are only 2 left. I can look up Al with pop, and because Al exists, I don't get a key error. And at this point, because I've deleted John and popped Al, I've only got one value left, which is Bob. And then finally I clear N to E, and N to E is now an empty dictionary. Okay, so to get ready for this next part, I had previously cleared S to S, student to scores, and I have now restored what the contents were. So S to S now contains the names and scores for these 3 students, Cal, Dave, and Ed. We saw that if you iterate through a dictionary, that by default what you get from the dictionary are the keys. So if I say for K, well, I can choose any variable name that I want. So let me say XYZ just for a change of pace. In S to S, print XYZ. And as we see, we get the keys from that dictionary. You can explicitly request the keys. I'm going to switch back to using K by using the S to S dot keys method. All right, this is what you get by default anyway. Or you can request the values by saying dot values. So for V in S to S dot values, print V will display the values in the same order that the keys were displayed. And recall that in a dictionary, starting in Python 3.7, the items in a dictionary are always stored in order of key creation. Now, the items of a dictionary are these pairs of values. So if I say for I in S to S dot items, This is an iterable that gives me back the key value pairs in tuple form, all right? So I'm going to get key, comma, value in parentheses, that is, as a tuple, from that, all right? So I have quite a bit of flexibility over how I retrieve the keys or the values or the items from the dictionary using these methods. Okay, and this slide 30 repeats one of the examples I just did, and here slide 31 shows the other two examples. If you choose to iterate through the items of a dictionary, each item is a two-tuple, as we've seen. You can use multiple assignment to conveniently break this out into separate key and value variables. So I previously said for I in s2s.items, and I iterated through these key value tuples, but I can also say for k comma v using multiple assignment in s2s.items and print, and v is the value. And notice that to make the output look nicer, I've thrown in a horizontal tab here to get somewhat more tabular output. Okay, so here's a nice table of the key and the value for each item within the dictionary. All right, now slide 33 coalesces something that I had mentioned before about how to create empty sets and dictionaries. Now, an empty tuple is easy because you just use an open and close parenthesis. An empty list, which I'll call a vector, is easy because you just use open and close square brackets. But both sets and dictionaries use curly braces. So the question is, what do you get if you just use an open and close curly brace? And the answer is you get an empty dictionary. Okay, so here with empty parentheses I got an empty tuple. With empty square brackets I got an empty vector. With empty curly braces I got a dictionary. And to get an empty set you have to use the construction name, the constructor name set with empty parentheses. And if you ask to see the type of SE here, now you're told that this thing is a set. All right, so that's how you differentiate both in definition and also in output between an empty dictionary and an empty set. So D displays as empty curly braces, SE displays as set and empty parens. Now to create a single item collection, recall we also had a funky thing with tuples. If we want a tuple containing one item, we have to say comma after the item value. Because if we just use parentheses without the comma, in this case that would simply set t1 to the int value 5 rather than to a one item tuple containing a 5. For a list, I just use square brackets and some value. For a set, I use curly braces and a value, so that's fine. And for a dictionary, I use a key and then a colon and then the value that I want to have associated with that key. Okay, so the only peculiar, funky situations are creating an empty set, which requires you to use the constructor name with empty parentheses, and creating a one-item tuple, which requires you to remember to use this comma. Okay, so we have an empty tuple, we have an empty list, we have an empty dictionary, we have an empty set. Whoops, sorry. SE was our empty set. And we also now have a one-item tuple, a one-item list, a one-item set, and a one-item dictionary. Python also provides something called a frozen set. Now, the only difference between a frozen set and a set is that the elements in a frozen set cannot be modified at all. Whereas a set is mutable, a frozen set is immutable, and therefore if you wanted to use a set as an element of a set or as a key in a dictionary, you can use a frozen set for that purpose. Other than to tell you that frozen sets exist, we're not really going to bother with frozen sets. All right, so that gets us to the conclusion of week 2, in which we have introduced the 4 built-in collection types that Python 3 provides: the list, the tuple, the set, and the dictionary. Okay, so in a list, we talked about how to define lists, how to index or subscript within lists. We saw that you can concatenate lists together by using the plus operation, or that you can repeat a list into a longer repeated list by using the star operator. A list is mutable. That is, we can assign new values in place of existing items within the list. We took a look at the for loop and talked about the concept of iterables. An iterable is any collection that you're allowed to step through one item at a time. In the case of a list object, the for loop goes through the items starting from item sub 0 and then item sub 1 and up to item sub n minus 1, where n is the length of the list. We introduced the idea of sequences as well, or the concepts of sequences. Now, a sequence is anything that you can iterate through in subscript order. Subscript sub 0, sub 1, sub 2, sub 3, etc. The list is an example of such a sequence, likewise a tuple, and likewise a stir. So you can access individual one-character long substrs within a stir by using sub 0, sub 1, sub 2, and so on. We also introduced the range function, which is an example of a sequence, although it's not a container type. It's a generator function. I haven't introduced the idea of generators yet, but it's a generator function that produces a sequence of integer values. Now, the list collection type has 11 named methods, and you should be familiar with all of those. We talked about the idea that variables are references to objects. The variable itself does not directly contain an object, and consequently you can have multiple different variables referring to a given object. For that matter, the data type of a variable is not specified in Python, and so a variable can at one moment be referring to an int, but then you can simply change that variable to refer to a float, or change that variable to refer to a stir, or change that variable to refer to a list or a tuple or a dict. All right? We took a look at the notion of IDs of objects. Every object has a unique ID number within the system, and you can use is and is not to compare whether two variables, or whether a variable and an object, a constant object, are references to the same object. All right, so you can ask whether I is j, you can ask whether I is 7, and if I happens to be a variable referring to the value 7, then because 7 is a small integer, I is 7 is going to give you a true result. You can use in and not in to detect whether a particular item value is in an iterable or not. I had to be careful there. I almost said sequence, but actually in and not in apply to non-sequence iterables such as sets and dicts as well. And you can find out the number of items in any collection, including a range, by using the len function. If you want to eliminate an object from memory and get rid of a variable, then you can use the del operation to eliminate a variable, and therefore if that variable is the only reference to an object, then that object itself is eliminated from memory. You can also set up a reference to none, which means that you have a variable that exists but is not referring to, well, it's referring to the one and only object, none, which does not have a value. All right. We also took a look at slices within sequence using the square bracket and the colon notation. And I told you / warned you that if you ask for a slice within a list, what you're getting is what's called a shallow copy. You will not get an entire deep copy of all of the items and sub-items and sub-sub-items contained within the list. You'll just get a shallow copy of a range of items within a list. We introduced the idea of tuple objects. Tuples are very similar to lists, except that tuples are immutable, whereas lists are mutable. The advantage of being immutable is that a tuple that only contains immutable objects, immutable items, is hashable and therefore can be used as a value in a set or as a key for a dictionary. We took a look at the idea of tuple packing, where you can give a variable name and an assignment operator, an equal sign, and then a sequence of values separated with commas. You don't even need to use the parentheses, and that will automatically be converted or packed into a tuple. We also took a look at the inverse of that, the idea of sequence unpacking, where you can have a number of variables separated by commas on the left-hand side of an assignment operator, and you can unpack from a tuple or from a list or from a stir or from a range, from any sequence, into those individual variables. We introduced set objects and a variety of symbolic and named operations for doing set versus set item operations, and also set versus set operations. A set is iterable. A set is mutable, but a set is not a sequence. You can use a for loop to step through all of the items in a set, one item at a time, but the order of those items cannot be specified, and if you try to use an integer subscript to access a particular set object, or particular set item, you will get an error message. Only hashable items can be stored in a set. And similarly, finally, for dict objects, a dict is a collection of key value pairs, and the keys have to be hashable. All right? So you can use the low-level built-in types, int, float, bool, stir, and none as keys in a dict. You can also use tuples that only contain hashable items as keys, but you can't use a list as a key or a set as a key. There's no restriction on values. All right, values in a dictionary can be any kind of thing. A dictionary is iterable, it is mutable, that is, you can change both the keys and the values within the dict. And a dict is not a sequence. That is, you cannot use integer subscripts to step through the items in a dictionary. But there are a variety of iterables that you can use with, for example, a for loop to step through all the keys in a dictionary, all the values in a dictionary, or all of the items, that is, all of the key value pairs within the dictionary. Okie dokie, so that is week 2.